Hey team, so in 6.1, what we're going to start doing in this chapter is we're going to start working with quadrilaterals, but we need to generalize polygons first of all, because we've only worked with triangles really so far. So now we got to work with the angles of bigger polygons than just the ones with three sides. So the goal of this front side of these notes is to work with the interior angles of polygons, and the back is we're going to work on with exterior angles. I guess there's not a back because this isn't a page, but if you want to read this little section right here at the top, it's going to prove to you why this formula is true. But if you want to try to find the sum of all the interior angles of any polygon, so that's any shape that has all straight sides, no circles or anything like that, no curved lines, then you're just going to use this formula that the sum of the interior angles is equal to 180 times n minus 2. Okay, and it all has to do with this proof about how many triangles you can cut up a polygon into. So let me show you a quick example of this. They worked out this example. I'll kind of visualize it for you. Then example 1, if you draw any convex polygon, remember convex means all the vertices are facing outward. They all have to be pointing out, can't go in. If it has 13 sides, then we can use this formula to find the sum of all those interior angles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 13-ish. Anyway, if you look at all these little angles, right, the sum of all those angles, all 13 of those, is going to add up to 1980. So that's what we're looking for. Obviously, I'm not a brilliant artist, but I will show you at least the math behind it. So we need to know what all these polygon names are. So remember, the decagon means 10 sides, octagon means 8 sides. The rest of them, they just tell us the number of sides, which is really nice. What we need to do is we need to just plug it into that formula to find the sum of the interior angles. Okay, so if we're finding the sum of the interior angles, what I tend to use for my formula is SI for my variable, just so I know it's the sum of the interior angles, because we're also going to work with exteriors, so that's why I use both. So the sum of the interior angles is 180 times n minus 2. If you want to put the parentheses n minus 2 first, like they did in the example above, you're more than welcome to do that. Okay, now the n here, the number of sides, is 8. So I'm going to plug in 8 for n. And I'm going to plug in my calculator 180 times 6, because 8 minus 2 is 6. And you get 1080. Okay, so the sum of the measures of the interior angles of any octagon, doesn't matter what it looks like, right? As long as it's a convex octagon, the sum of the measures is going to be 180 degrees. Okay, let's do the same with the 16 gon. So SI equals 180 times 16 minus 2. So I need to plug in the calculator 180 times 14. And I get 2520. Okay, and lastly, the 35 gon SI equals 180 times, my handwriting is miserable in these videos. 35 minus 2, which is 33, so 33 times 180, trusty calculator says 5940. Okay, so I don't know what each of them are, but I know they all add up to 5940, just like the angles of a triangle add up to 180. These add up to these numbers, okay? Now, this next section is working with regular polygons, okay? So the distinction in the second one is that we've got regular polygons, okay? Remember that regular means all the angles and all the sides are the same. I can't stop playing that noise. So all the angles and all the sides are the same. So let's go back to that octagon example, okay? So if I actually draw a regular octagon, that one was for any octagon, but let's just say that I drew a perfectly regular one where all the angles and sides were the same. Okay, so all the sides have slashes. I'm not going to draw the angle slashes because it won't even look like an octagon anymore, but all the angles would have slashes too because they're all the same. All right, the way to find the measure of each of those, if it's regular, is you just do the sum part like we did, and then divide it by the number of angles that there are. Okay, so for an octagon, there's going to be 8 angles, so you would divide that 1080 by 8, and you would find each of the measures of those angles. Okay, so what we're going to do is we're going to actually work backwards here. I'm going to give you the measure of each interior angle of these, and you're going to work backwards to find that n, find the number of sides. Okay, so what I need to do for this 150, right, if I know it's a regular polygon, I know that the sum of the interior angles is going to be the same as each interior angle multiplied by however many sides there are, n. Okay? Because, for example, in that octagon, right, you know that each of those, if you multiply by 8, it has to equal the sum of the interior angles, which was 1080. So that's always the case. So that's going to be equal to my 180 times n minus 2. Okay, now what I have to do is I need to solve for n. Well, they gave me EI already. They gave me each interior angle is 150 in this first example. So I've got 150n equals 180 times n minus 2. And you just have to do a little bit of algebra to solve that. So I'll go ahead and do that right now. Let's zoom in here so we can see it a little better. Okay, so I need to distribute the 180. And then I'm going to bring all the n's to the left. Keep the 360 on the right. So I get 150n equals 180 n minus 360. Alright, subtract the 180 over. So I get negative 30n equals negative 360. And when I divide by negative 30, I'm going to get n equals 12. Okay, you should always get a positive answer, obviously, for the number of sides. You can't have a negative number of sides in your angle. Okay, let me do another example for that. We'll do the 144. Okay, so for 144, all right, remember that we've got this is each interior angle. So if I multiply that by the number of sides, n, then that's going to be equal to 180 times n minus 2. Now that right side of that equation is going to look the exact same every time. It's always 180 n minus 360. So you can eventually start just writing 180 n minus 360 and save yourself a step. Okay, you're going to subtract the 180 n over to get negative 36n equals negative 360. Divide by negative 36 and you get n equals 10. So you should always be getting a positive number. So I know that this has 10 sides. So if it's a regular polygon, that has each interior angle as 144 degrees. All right, we already know one example that of all the interior angles of a regular polygon. We know that all the regular of a regular triangle, an equilateral triangle, it's always going to be 60. It's the same process for this. So lastly, number 9, we'll do this one. So 180n, that's my EI. Okay, so 180n equals 180 n minus 360. Okay, so this is my formula. Okay, 180 times n equals, or sorry, EI times n, each interior angle times n equals 180 times the number of sides minus 2. Alright, so I need to subtract my 180n over, so I get negative 5n equals negative 360, and divide by negative 5, and I get n equals some things. Let's see. I should be able to do that in my little brain. Oh, it's 72. Duh. Okay, so the number of sides of that polygon is 72. Alright, now the last type of problem that you could get on this one. Right, something like this. Okay, where you have to find x. Okay, so what I need to do here is I need to use that information that I just learned how to find the sum of the measures of the interior angles. This is clearly not regular, okay? All the sides and angles look all different. But what I can do is I can see how many sides there are. 1, 2, 3, 4, 5. Those slashies don't mean the same, but it just means there's 5 sides, okay? I'm just counting the sides, so I've got 5 sides here, so I can find the sum of the interior angles. SI equals 180 times 5 minus 3. 2, 3. As soon as I wrote it, I realized how stupid I was. Okay, so the sum of the interior angles equals 180 times 3, which is 540. So what that tells me is I can create an equation that this plus this plus this plus this plus this equals 540, and that'll help me solve for x. So I'll go ahead and do that right now. 7x plus 4x plus 10 plus 6x plus 10 plus 5x minus 5 plus 4x plus 5 equals 540. Okay, so I can combine all the like terms. 7, 11, 17, 22, 26. So 26x plus 20 equals 540. So 26x equals 520, and x equals 20. let's go to the back side, do the exteriors. So for exterior angles, it's harder to picture what an exterior angle actually is, but it's so easy to calculate, which is really nice for us. Okay, so what we need to know about exterior angles is the way you create them is by taking a polygon. So we look at this polygon right here. All right, if you just extend all of the sides, it's going to create exterior angles. So there's an exterior angle. That's an exterior angle, exterior angle, exterior angle. Okay, similar to what we did with the triangles. Okay, those are exterior angles. So we can find the measures of all those exterior angles. The nice part about this is the sum of the exterior angles is so easy. It's literally the easiest formula we're going to see all year. It's always equal to 360. Okay, there's no calculation involved. Doesn't matter. Literally nothing matters except that it's always going to be 360. Okay, so you just have to memorize that. When you got to find each exterior angle, like in example 2, all you're going to do is divide that 360 by the number of sides, because you're only going to be able to do that with regular polygons. So that will help you out right there. So I'll show you what this looks like. These are going to be the easiest problems on all of your tests. Okay, so the first directions here says find the sum of the exterior angles. Okay, sum of the exterior angles. We know that the answer is always 36. 360, I'm sorry, not 36. Bam. Okay, easiest thing ever. Now, for these other ones, we need to know the number of sides, so I'll write these down really quickly as a review. 6, 7, 12, and 8. Okay, and we can find these answers very quickly, okay, because each exterior angle, if it's a regular polygon, remember it has to be regular, but it's always going to be in the directions. Okay, you just take that 360, the total, and divide it by the number of sides. So if I need to find each exterior angle, it's 360 divided by n. Okay, for this first one, it's that n is going to be 12, because it's a 12-gon, or a dodecagon, and 360 divided by 12 is 30. So each one's going to be 30. Okay, if I skip over to the 20-gon, I've got 360 divided by 20. Okay, again, easy to do. 18 degrees. Okay, let's do the heptagon. 360 divided by 7. Okay, this one I'm going to need a calculator for because it doesn't come out perfectly, I don't think. I get about 51.4 degrees. I just round that to the 10th place. That's plenty. And you get the idea. Okay, so that's it for section 1.